We're going to take a look at properties of exponents involving quotients. So let's take a look at a quick example where we have something like n to the 10th power divided by n to the 7th power. And this is a quotient because we have division going on, we have a fraction, and these two terms have the same base and they're being divided. So what I want to do is expand these two things out and sort of see what happens, what this simplifies to. So we have n to the 10th, well that expands out to 10 factors of n. 4, 5, 6, 7, 8, 9, 10. Over n to the 7th, that is 7 factors of n. So 1, 2, 3, 4, 5, 6, 7. Now, each time we have a pair of an n in the numerator and an n in the denominator, we're dividing something by itself and getting 1. So you might think of this as canceling out, but this n and this n, they have divided out and they're just now 1. And multiplying or dividing by 1 doesn't change anything. This n and that n divide out to 1, this n and that n. Every pair of n's that we have divides out and just gives us 1. So if we divide out 7 of the n's on top with 7 of the n's on the bottom, what we're left with are these 3 n's all together. Well, let's condense those back down, and n times itself 3 times is just n to the 3rd. So what we started out with was n to the 10th divided by n to the 7th, and what we ended up with was n to the 3rd. What you might be able to see here is that all we really are doing with these two exponents is just subtracting them. But let's take a quick look at one more and see what happens when the exponent in the denominator is bigger than the numerator. So let's take a variable here. Let's call it, I don't know, h. Let's say h to the 5th divided by h to the 7th. Well, in the numerator here we have 5 factors of h. And in the denominator we have 7. 4, 5, 6, 7. So just like before, every time we have a pair of the same terms in the numerator and denominator, those divide out and give us 1. So those h's divide out to give 1. Those ones divide out to give 1. Those ones divide out. They're gone. Those ones, they've all divided out. Now we're left with nothing on top. Well, it's not really nothing on top. We have sort of an implied 1, sort of a placeholder 1 on top. And we have 2 factors of h left over in the denominator. So let's condense those back down, and we have h squared. So just like before, our exponents got subtracted, but I want you to notice where that ended up. This time the numerator was smaller than the denominator, and when we subtracted, the 2 was left over on the bottom in the denominator. So the important thing to know here is that when we're subtracting, the term is going to be left in the spot that had the larger exponent to begin with. So 7 was bigger here, so our h term ended up in the denominator. So that brings us to the quotient rule for exponents. If two exponential terms have the same base and are being divided, then their exponents are subtracted. And typically we do that in the order of the numerator minus the denominator. Now it's possible that if you do that, like the one we saw before, we had h to the 5th over h to the 7th, subtracting numerator minus denominator would have given us 5 minus 7, which would be negative 2. But we saw that it actually turned out to be 1 over h squared. And we're going to be dealing with negative exponents like that later on. So just kind of a preview here that if you see a negative exponent, what that really means is reciprocal. But we don't need to worry about that just yet. Let's take a look at a few examples. Let's bring in some stuff from before too, some of the product rules. So let's say we have 2x squared to the 3rd divided by 4x to the 4th. Well, let's go ahead and use our product rule up here. 2 is being raised to the 3rd to get 8. X squared is being raised to the 3rd, so we're going to multiply those two exponents and get 6. In the denominator, we have 4x to the 4th. So the 8 divided by 4, that is going to give you just 2. And then x to the 6th divided by x to the 4th, we're going to subtract those exponents and get x squared. So all of this simplified down to 2x squared. Let's take a look at one more here. Alright, so here we have 20n to the 3rd over 25n to the 5th times n squared. First thing we might want to do is condense these two n terms together in the denominator. So let's leave the 20n to the 3rd how it is, divided by 25n to the, well, we're multiplying those, so we'll add the exponents and get n to the 7th. So let's reduce what we can. The 20 over 25, those are both divisible by 5, so that would reduce to 4 over 5. Now we have n to the 3rd and n to the 7th. Well, when you subtract those, you get 4. And because there are 7 factors of n in the denominator, we're going to be left over with those 4 in the denominator. So this expression will simplify to 4 over 5n to the 4th. One last little detail about this quotient property is if you're taking a fraction itself raised to a power. So I want to take a look at, let's say, x over y raised to the 4th power. The base that we have is x over y. That's being raised to the 4th. So we're taking that base times itself 4 times. And we are multiplying these all together. So if you multiply straight across the top, we have 4 factors of x, so x to the 4th. 4 factors of y, so y to the 4th. So what I want you to see here is that when you're taking a fraction and raising that to a power, well, both parts of that fraction are being raised to the power, the numerator and the denominator. So with that in mind, let's take a look at one more example. Let's say 3n to the 5th over 2n squared, and that's being raised to the 3rd power. So because this is all in parentheses here, being raised to the 3rd, well, the numerator is being raised to the 3rd, and 3 to the 3rd is 27. And n to the 5th to the 3rd, we'll multiply those exponents and get n to the 15th. Now the denominator is also being raised to the 3rd, so 2 to the 3rd is 8, and n squared to the 3rd, multiply those exponents and we get 6. Now we can condense a little bit more because we have common bases here. So 27 over 8, those have no factors in common, so that won't reduce at all. And n to the 15th divided by n to the 6th, we'll be subtracting those exponents and getting n to the 9th. And that's going to go in the numerator because that's where we had more factors of n to begin with. So this all together, after using our power to a power rule, simplifies down to 27n